Ladies and gentlemen, please welcome our keynote speaker on stage. Keshan Sodimana, Associate Architect Machine Learning at LSEG and former Country Engineering Consultant at Google.
Well, picture this. A few million years ago, our ancestors, the Homo sapiens, may have tried to communicate with each other, right? Using different sounds, different hand gestures, and they came up with something called language, right? So, which was a powerful tool they could, which we were able to develop as languages that we speak today. What happened was this evolved, and today, although it's a powerful tool, people are using for some, you know, some stuff that we don't like. But still, the language can be so powerful. It can be even used to express emotions, like love. Anyway, so in the 20th century, when people were started to came up with this industrial revolution, and humans have evolved into some ways where they could automate some of their tasks, like especially the mechanical tasks that they were doing, all the labor tasks, and they were able to come up with these new machines. And one of such machine was the computer, which they wanted to make human brain like more machinery. So in early 50s, early 1950s, Alan Turing was one of the pioneers who introduced these concepts like artificial intelligence. He was even talking about the artificial intelligence that we are kind of experiencing today. So he came up with this thing called Turing test. I think some of you may have heard of the Turing test. So Turing test is basically a kind of a thought experiment. We can say it as a thought experiment where he said that if a computer gives us a response, and if we cannot distinguish whether it's a human or a computer, then we can consider that as a pass of a Turing test. So if you imagine right now, today we have systems like ChatGPT, Bard. Sometimes we feel like it's not a machine, it's more like a human, right? Do you feel it? Have you used Bard or ChatGPT or something like that? No one? So there's a tool right now available. You can try searching on Google. BARD, that is Bard, and the other one is ChatGPT, ChatGPT. Okay? So just search for it, and you might be amazed. It can do something we might not be able to identify whether it's a human or a machine, right? So I want to know who the guys who doesn't have any idea about ChatGPT or Bard. Can you raise your hand? Because I want to do a research on the people who haven't used these tools and come to this session. Because even my 70-year-old mom knows about ChatGPT. Okay, so do you know this one? So this is called Eliza, which came up in the early 60s. Think of as the first chatbot in the world. Consider as one of the first chatbots in the world. Eliza was very, very primitive if we think in terms of the tools that's available right now. But Eliza inspired the series of chatbots which came up since 60s. So Eliza was one of the great grandmothers of ChatGPT and Bard that we have right now. But if you think this kind of a program, maybe even a primary level student may code this kind of a program right now today. But it was one of the pinnacles back then in the 1960s when humans could be able to converse with a computer in a natural language, in a human language. So that was pretty amazing back then. Now, today we have come to tools like Gemini. Gemini is a model which was introduced a couple of days ago by Google. It is considered as the most powerful model available right now. Although I think we don't have a public availability right now for the Gemini, but it will power tools like Bard in the future. So Gemini, actually talking about Gemini, I would like to play this video for you. It's by Google, so just listen to it.
If I were to look at the foundational breakthroughs in AI over the past decade, Google has been at the forefront of many of those breakthroughs.
Gemini is our largest and most capable model. It means that Gemini can understand the world around us in the way that we do. So not just text, but also code, audio, image, and video.
Taylor used Gemini to search a large corpus of scientific papers for key information.
We wrote a prompt. With its advanced reasoning capabilities, Gemini was able to distinguish between papers that were relevant to the study and those that weren't.
I'm delighted to introduce AlphaCode 2, powered by Gemini. When we evaluate AlphaCode 2 on the same platform as the original AlphaCode, we solve almost twice as many problems.
Gemini on its own has the ability to transform software development as we understand it.
Based on their design, which of these would go faster?
The car on the right would be faster. It is more aerodynamic.
But safety and responsibility has to be built in from the beginning.
And that has oriented us to be both bold and responsible together.
Developers and enterprise customers are going to figure out really creative ways to further refine our foundational models.
Gemini will be available in 3 sizes. Gemini Ultra, our most capable and largest model for highly complex tasks. Gemini Pro, our best performing model for a broad range of tasks. And Gemini Nano, our most efficient model for on-device tasks.
It's been a monumental engineering task, which has been, very challenging, but also very exciting.
Right. So that's about Gemini. Gemini can do wonderful stuff. Not only language-to-language conversations, but it can also work with multimodal. So let's go back a bit and see how this entire revolution happened. So this was not happened in 10 years or 20 years. Actually, this trend was there since 50s, as I said earlier. Alan Turing talked about these concepts, and then in the 60s, there was some research on neural networks. But neural networks were not really cool back then, even in the 60s or even in the 90s. It was not a cool thing because nobody thought that neural networks could do wonderful things that we are experiencing right now. Actually, neural networks are the workhorse in all these language models that we are experiencing right now. So in 2012, there was a competition. Actually, this competition was there even before 2012. But in 2012 competition, this ImageNet competition was by DARPA, and they are sponsoring this competition. Professor Hinton and Professor Jeffrey Hinton and his team came up with this new model, which used neural networks, and also it trained on GPUs. Do you know what GPUs are? Anybody play games? No? Wow. So, okay. I think it's a generational thing because in our generation we used to play games. I don't know about you, but yeah, that happened in our time. Like in early 2000s, maybe in the 90s, like kids really wanted to play games, and the GPUs are coming with, GPUs are mainly introduced for the gamers, but then people started using GPUs to train neural networks because it's doing multiplication, the matrix multiplication very efficiently, and people saw that it could be used to train neural networks as well. And now most of the companies like NVIDIA, they are mostly focusing on developing GPUs and other hardware for neural network training because that's a big business for them rather than concerning about the gaming. Now, talking about the ImageNet, this competition was the first time that neural networks was used successfully. And they could achieve results which were far better than the previous models. And that's when people realized, okay, we can use neural networks and we can use GPUs and other types of hardwares to accelerate these new models. So especially it's come up with, initially neural networks were used for the image tasks, especially on the computer vision side. So computer vision was pretty peak in 2014, 2015 that time, but NLP caught up in the last few years, and now we are seeing so many amazing stuff. Now, what changed? So actually, there were 3 main things. One thing is our lives went digital and everything was on internet, right? So there were lots of data available for, especially for the bigger companies and also for the smaller research groups as well. So the data availability was one key thing that made this new revolution. And also, as the Moore's law predicted, the hardware became so powerful. So I was talking about GPUs, but there are new hardware like TPUs and other processors which are being developed to do this stuff. And also because of the previous two, there were many researchers started working on these tools and came up with some powerful and efficient algorithms. So all these three things helped to revolutionize this new paradigm. And so that was the snowball effect. So everything started and then it grew rapidly. So after they saw the opportunities in these new technologies, these new models, many companies started investing. Companies like Google, Microsoft, they started investing. And they started creating new teams, new developers, and many researchers came in and everything, took a very accelerated approach. And that's what we see today as the result of all these things. So this is the model behind the language models that we are experiencing right now. Okay, it's something pretty distorted, I know. So initially, this is called the transformer model. Transformer, not the transformer that the movie, but it's a model. So this transformer has two things like encoder and the decoder. So initial transformer was introduced back in 2017 by the researchers at Google. They introduced it as it for a translation project. So initially it was basically getting English inputs into German outputs. So that was mentioned in the paper. And what happened in around 2018, 2019, OpenAI came up with this new idea where they removed the encoder part and they just got the decoder part, only the decoder part. And they started training this model, asking it to predict the same language. I mean, given a sequence of words, it asked the model, trained the model to predict the next possible token, next possible word, you might say. So that's become the GPT model that we are experiencing right now. So the GPT-1, GPT-2, they were good. I mean, it was very famous among the small NLP community, but it wasn't that popular among the larger audience. But in 2020, they came up with this new model called GPT-3. So they trained it with a bigger data set for longer time, and it takes millions of dollars to train such a huge model. But nobody was aware about GPT-3 in 2020. So one reason could be the COVID, because it took the spotlight in 2020. And the other reasons could be there were not much use cases for GPT-3. But then later, after 2020, they started training these models with some new techniques called RLHF, those kind of new techniques using different data sets. So they experiment so many new stuff. And 2022, they released ChatGPT. I think the rest is history. Everybody probably know about ChatGPT. And that's about the transformer model. Now, transformer model, one of the good thing about transformer model is it's pretty simple in terms of mathematics. It's very simple model. Although the jargon, the diagram that you saw was bit bit messy. It's not only trained text-based models, but it can be trained on images, features, and structured data like tabular data, and also different other modalities as well. And also it can adapt to different other tasks like question answering that you may have already experienced, and sentiment analysis. Those kind of tasks maybe you're already familiarized with. And image captioning, image generation. So the new Gemini model can do this stuff like multimodal things. So this can be achieved with this generalized model. Now, let's think a bit about language model with an analogy. So this is an analogy. This is not a correct picture, but in order to get a simple analogy. So let's imagine that that there's a, so this entire thought experiment is called the Chinese room problem. This was introduced back in, I think, in 1980s. It was a philosophical argument to validate some of the AI concepts, not the language models, because in 1980s they were not aware about these language models. But the thought experiment was this. So there's a room, inside the room there's a person, and this person doesn't know anything about Chinese, right? I'm getting Chinese not for any particular reasons, so don't think about the Chinese word, or you can replace it with any language, Japanese, whatever, German, French, or anything. But for the sake of this argument, they introduce it as the Chinese room problem. So this person doesn't know anything about Chinese, but he has a huge book. So given some kind of scribbles, kind of how to say it, some notations, some special notations, he can he can come up with a rule. I mean, there are some rules to how to write the response in that book. So what happens is the person outside the room who speaks Chinese, he sends a message into the room, and the person who is inside the room pick up the message, and he tried to find what are the similar patterns in mentioned in the book, and then based on that pattern, he will just come up with an answer and give back to the person outside. And when the person who is outside the room sees that answer, he's amazed. Like he thinks that the person who is inside the room speaks Chinese fluently, because the answer matches very, very well. But the thing is, the person inside the room has no idea about Chinese. He doesn't speak Chinese. He doesn't read Chinese. But his rule book has all the combinations of the Chinese characters that he can answer with. So that's an analogy, right? So language models are a bit similar to that. It's not, 100% the similar, but it's pretty much same, because it was trained with like large set of data. Like right now, it's about the public data sets that's available right now, and also the companies like OpenAI has their own proprietary data as well. So they have been trained with huge, all the human knowledge that's available on internet. And it has seen so many words, so many sentences, so many combinations of sentences, and based on that, it has a probability. So, like, given a set of words, it has a probability what should be the next word that's most probable, right? So based on that, it can predict sentences which we feels like this is a human, not a machine. Now, there are things when we are talking about language models, there's a phase called pre-training. So companies like OpenAI, Google, they do this pre-training part, because it's very computationally expensive, and mostly people like us, like small researchers, may not be able to do such things because of the budgetary issues, because it takes millions of dollars to train a huge language model. Although, like yesterday, we trained a very small model in our code lab, but that's a very smaller model. But if you want to train a sophisticated model, which could be used in the commercial application, then you need to spend a couple of millions of dollars to pre-train a model. And then we have this next phase called fine-tuning. Let's say you have a use case. Maybe you are from a medical domain, or maybe you are from a financial domain. Then you have to collect some data set for your domain, and you can do something called fine-tuning. Fine-tuning to adapt that model into your particular use case, and also maybe you can come up with an instruction data set to instruct tune it. And then you have the inference phase. Inference means you are asking questions, or you are getting predictions from the model. Now, there's another I was mentioning about the fine-tuning. So there's one thing called domain adaptation. As I said earlier, if you are from a different domain, like medical or financial or different domain, then you can get a pre-trained model, and you can adapt it to your subdomain, particular subdomain. It's good if the model has already seen or already trained with your domain data, but most probably, if you have a larger data set, you can adapt it to some level to your subdomain, and then you can do the fine tuning with some specific data. Maybe if you have instruction data, if you have a particular task to do get done by the model, then you need to come up with this instruction data set. Maybe it could be a question answering task, maybe it could be a reasoning task. You have to collect the data accordingly and then do the fine tuning, the instruct tuning on the model. Now, the future will be not just language to language models, but there will be multimodal architectures like the BART that we saw, the Gemini demo that we saw in earlier. Like it will be able to work with not only text but images, audios, videos, and other modalities as well. So this will be the future, I guess, because it's hard to predict future right now, because whatever I say today may not be valid tomorrow. That's how fast, how rapidly this AI industry is growing. So, but I'm pretty sure this will be something that will come up in the near future. Multimodal architectures. Do you know this one, this movie? By the way, do you watch movies? You don't play games? Don't use ChatGPT or Bard? Do you at least watch movies? So how many of you know this movie? What is the movie? What? I can't hear you. I'm a bit old. I can't hear you. Her, yeah. This is a movie Her in 2014, if I remember. So why I put this slide? Because this movie, I mean, the way we will be interacting with computers and machines will change. I think it will change in the near future. So this movie is basically about. So I'm not going to spoil it. You have to go and watch it. So the only thing is that I want to say is that the way we will interact, way we will be interacting with computers or the mobile phone or other machines will change in the future. It will not be simply typing or giving instruction, maybe even coding. That may be changed in the future. That's a prediction. I may be wrong. So this idea, actually, okay, I want to say that this guy is called Andrej Karpathy, AndrejKarpathy, Andrej Karpathy. You should follow him if you are interested in learning about AI. This guy is a genius. You should follow him. He has wonderful videos and courses. So his idea is actually he's working at OpenAI. He's one of the top researchers at OpenAI. And one of his idea was this LLM OS. I mean, large language models in terms of an OS. So an OS has components like file systems, and it can work with, it has a Python interpreter. It can do code interpretation, code compilation, all these things. And it can access browsers. So what we do right now is we use a computer to access all these different services, right? So we take decisions and we do stuff with the computer. But his idea is think of this LLM as the brain of the computer, and it can operate these different components. Like it can access file systems, it can access internet using a browser, it can access Python interpreters or other programming languages, and it can coordinate and orchestrate all this stuff for us. So in that way, as I said earlier in the Her movie example, the way we will be interacting with the computer will be change a lot. Now, what's coming up in the future? So OpenAI was talking about AGI. I think there was a drama a few weeks ago at OpenAI. I don't know anything about it, but one thing that they are talking about is AGI, artificial general intelligence. So not only general intelligence, actually they are talking about super intelligence as well. So right now we are in a phase called we may be, as far as I know, I don't know about what's happening inside OpenAI. As far as I know, we are still in a phase called artificial narrow intelligence, where the models can do whatever we train the models to do, but it cannot adapt and do things like a human. But they're talking about models that we can train to adapt and work like a human. So that is where AGI comes in. And in the recent drama, I think they were talking about Q-star algorithm. I don't know what these things are. Don't ask me about those stuff. But I think the reason was something about AGI as well. That's what they are telling to us. So the thing is, when we are working with artificial intelligence, I think we have to think more about this stuff like responsibility, how to be fair, because these are models which cannot take decisions. I mean, it takes decisions based on the data that we trained it on. So we have to be responsible, and we have to be, it should be governable. Like, let's say, for example, in an unlikely event if the models take over us, take over humanity for some reason, I don't know. If that happens, then there should be a way to govern this model. So the governance should be there as well. So as enthusiasts, ML or AI enthusiasts, probably we need to think about these things as well when we are developing these systems. Last but not least, will the AI be sentient? And if or when it happens, can we accept that reality? Thank you.
Thank you, Keshan, for that wonderful keynote speech. So there's a small token of appreciation from GDG Sri Lanka to Mr. Keshan Sodimana. So I'd like to invite you over to the stage again. And to present this token of appreciation, I invite over to the stage Mr. Tarak Devinder, a former organizer of GDG Sri Lanka. Let's give them a round of applause, ladies and gentlemen.